Welcome to section 14.2, part 1. This is the 150th session of the CISSP exam prep series. This part turns from access models to the systems that carry authentication across the web. In this session, we'll study how single sign-on works on the internet. Why should you never hand your credentials to a third party? How does SAML let organizations trust each other? How does OAuth share access without sharing passwords? How does OpenID Connect add authentication on top? And how do these three compare? Why does this matter beyond the exam? Because you will design logins that touch other companies you do not control. Picture a travel booking app that lets users sign in with an existing email provider. Behind that one friendly button sits a careful dance of trust between separate organizations. Understand the dance, and you build integrations that are both smooth and safe. Miss it, and you either frustrate users or leak credentials across systems that should never share them. Let's start with the core problem these systems solve. Why should you never hand your credentials to a third party? Imagine wanting to move money from one bank to another. You would never give the second bank your login for the first. That would hand over the keys to your entire account. The whole point of modern authentication standards is to let one service act on your behalf without ever seeing your password. They share proof of who you are or what you may do, while your secret stays put. Most of these standards speak a shared language first. What is the role of XML here? Extensible markup language does more than format data for display. It describes what the data actually means, wrapping each value in a descriptive tag. Because vendors from many systems can read and write it, XML became a common tongue for exchanging information. Several of the authentication standards you will meet are built on dialects of XML rather than the raw form. Think of it as the neutral grammar that lets different platforms understand one another. Now, the first major standard. How does SAML let organizations trust each other? Security Assertion Markup Language is an open XML-based standard that carries authentication and authorization details between federated organizations, and it powers single sign-on in the browser. It runs on 3 players. The principal is the user trying to reach a service. The service provider is the site the user wants, like an investment portal. The identity provider is the trusted third party that actually holds the credentials. The user hits the service, gets redirected to the identity provider to log in, and the identity provider sends back signed assertions confirming who they are and what they may access. What exactly does the identity provider send back? 3 kinds of statements inside those assertions. An authentication statement confirms the user proved their credentials, by which method, and at what time. An attribute statement carries facts about the user, such as their entitlements. An authorization statement declares whether the user may reach the requested service, and if not, why. Cloud providers love bundling SAML into their platforms because it hands their customers clean, ready-made single sign-on. 1 redirect, 3 answers, and the service knows exactly who it is dealing with. Now a different tool for a different job. How does OAuth share access without sharing passwords? OAuth is an authorization framework, not an authentication protocol, and that distinction matters. Picture a scheduling app that wants to post to your social media account. Instead of taking your social password, it redirects you to the social platform, which shows you exactly what the app is requesting and asks you to approve. And the platform hands the app a token, not your credentials. The app then presents that token whenever it acts on your behalf. Even if that app is later breached, your actual password was never exposed to it. Note that OAuth grants access, but it does not by itself prove who you are. So how do you add identity on top of OAuth? With OpenID Connect, it is a thin authentication layer built on the OAuth framework, and its key feature is that it delivers both authentication and authorization together. It carries a signed token, a JSON web token, that a service retrieves to confirm the user and can even include profile details about them. You see this every time you log into one site using an account from a large provider, and the whole handshake happens quietly in the background. OAuth answers what you may do, and OpenID Connect adds the answer to who you are. Let's line the 3 up side by side. How does SAML, OAuth, and OpenID Connect compare? SAML is the XML-based standard with 3 entities, delivering authentication, authorization, and attributes. and it shines for browser single sign-on between organizations. OAuth is a pure authorization framework that trades tokens through application interfaces, so an app can act for you without your password. OpenID Connect sits on top of OAuth, adds real authentication, and carries a JSON web token as its identity proof. If you remember one line each, that is your exam anchor. Assertions, authorization only, and authentication layered on OAuth. Now we move inside the walls. How does single sign-on work on internal networks? Inside an organization, the dominant single sign-on method is a ticket-based system we will detail shortly. Remote workers also need to reach internal networks from afar, and two protocols handle that access. Beyond simply enabling single sign-on, they deliver the full trio of authentication, authorization, and accounting. That combination is important enough to earn its own family name in the next concept. Inside the network, the goals shift from cross-company trust to centralized, auditable control. What are authentication, authorization, and accounting protocols, and why do they matter? These are protocols that provide those three services from one central point. They sit in front of remote access systems, like virtual private networks and other network access servers, and give one shared place to verify and record every connection. That central design also isolates risk. If someone attacks the remote access path, the damage stays with remote users and does not automatically reach internal accounts. Authentication confirms valid credentials. Authorization confirms the connection is allowed. And accounting tracks resource usage, which can even feed billing. One gatekeeper, 3 jobs, and a clean audit trail. So let's bring it together. The guiding rule is never to share your credentials with a third party, so these standards share proof instead. XML is the shared grammar, and SAML uses it with 3 entities to federate single sign-on across organizations. OAuth grants access with tokens and no password, while OpenID Connect layers authentication on top using a JSON web token. Inside the network, single sign-on and remote access lean on protocols that centralize authentication, authorization, and accounting. In part 2, we go deep on the ticket-based systems that run the internal side. The MCQs covering all the topics and concepts from this session are available on rucloud.com. Practice the chapter-specific MCQs before moving on to the next session. Thanks for watching. If you have any questions or feedback, post a comment below or email us. I will see you in the next session.